Hello everyone, I am Dr. Skraup. I welcome you in my YouTube channel. Today in this video, I am going to talk on quinoline. You know, quinoline is also an important heterocyclic compound. So I will discuss first aromaticity, then preparations of quinoline, and then reactions of quinoline, and I will discuss about the uses of quinoline. So let us start learning of quinoline. You can see the structure of quinoline. First positions in quinoline start with the nitrogens, and this is very important concept for you. So look at here. Nitrogen 1, carbon 2, 3, 4, and most important, the fuse carbon will not go regular numbering. So after 4 you can see the 5. Fuse carbon is not counted here. So 5, 6, 7 and 8. The other name of quinoline is one is a naphthalene, benzo-B-pyridine. This is the B showing the positions of attachment of the ring. One side pyridine, another side benzo, and attachment with the bond, and that bond name is B. So benzo-B-pyridine. And another name, one is a naphthalene because it is a derivative of naphthalene. Now, my friend, the another concept related to quinoline, keep in your mind, each atom is sp2 hybridized, planar. The total number of delocalization electrons are 10, 9 from 9 carbon and 1 from nitrogen. Follows the Haeckel's rules. Now, another important properties is weak base and hydrogen bonding. Now synthesis. First synthesis is Skraup Quinoline synthesis. You know, quinoline from aniline, glycerol, sulfuric acid and mild oxidizing agent. What is mild oxidizing agent? Nitrobenzene. You know, reaction is exothermic. So what precaution you will take? Exothermic means heat will remove, produced during the reaction. So reaction is exothermic and tend to be violent. Thus ferrous sulfate is added to make it less violent. Look at the structure, aniline, glycerol structure. Then you see the arrow, and up the arrow sulfuric acid and down the arrow nitrobenzene. Then the formation of your product, which is your requirement, quinoline. Now see the mechanisms. What will happen? So first, conversions of acrolein. What conversion of acrolein? You can see glycerol remove 2 water molecules in the presence of sulfuric acid. It will produce acrolein. See the acrolein structure. This is alpha beta unsaturated aldehyde and functional group aldehyde is present, but the starting compounds all alcohol is only present. Now acrolein reacts the aniline and forming carbon nitrogen bond, and nitrogen have the positive charge, conjugate additions, and then O minus trap H plus and forming OH, and then double bond approaching H plus forming the enol form. Then keto-enol tautomerism, you will get the keto form, and then you can see the intramolecular addition, and then cyclization occurs, carbon-carbon bond formed here, and then aromatizations minus H plus forming this product, and then in acidic medium OH2 plus and then remove water molecule, which is known as dehydrations, you will get this cyclized product. And then oxidation, you will get the quinoline. So take the copy and pencil and write it down 2 and 3 times this Skraup Quinoline synthesis mechanism. Then you will be in your memory. It will be in your memory. Otherwise you will lose. Now, Doebner-Miller synthesis. The organic reactions of aniline with alpha-beta unsaturated carbonyl compound to form quinolines. You can see the aniline, you can see the like acrolein. This is the alpha-beta unsaturated ketones. It will give your cyclized product. Now, Friedlander synthesis. Friedlander synthesis is the chemical reactions of 2-amino benzaldehyde. There is a difference because previous 2 reaction we took aniline. Here 2-amino benzaldehyde with ketone to form quinoline derivative. You can see the formation of quinoline which is substituted at 2 positions. Now reactions of quinoline. Electrophilic addition to nitrogen. Look at the react with HCl forming quinazolium salt chloride. Quinazolium salt chloride. Another example, 1-methyl quinolinium iodide. Now, my friends, you can see the electrophilic aromatic substitution. Electrophilic aromatic substitution occurs at the benzene ring at the position 5 and 8. And this position is very important, 5 and 8. Look at here, nitro group goes to 8 position and 5 position, both product is there. In bromination, bromine goes to 5 position, 8 position. And in sulfonation, sulfur groups go 5 position and 8 positions. Now, my friends, reductions reactions. There are many types of reductions here. In presence of lithium hydride, in presence of platinum oxide, and hydrogenation in the presence of platinum, you will get the 1, 2, 3, 4 tetrahydroquinoline. In presence of dehydrogenation occurs at the platinum. In presence of 12 NaCl, then you will get the 5, 6, 7, 8 tetrahydroquinoline. Another important reaction related to quinoline is oxidation. You can see in presence of alkaline KMnO4, it will give pyridine 2,3 dicarboxylic acid, which is unstable. Remove carbon decarboxylation occurs at this stage and nicotinic acid will form. Now reaction, nucleophilic substitution. Nucleophilic substitution, most important examples is Chichi-Bibin reactions. You can look at the Chichi-Bibin reactions. Reaction with sodamide at high temperature, you will get the 2-amino quinoline, which is known as Chichi-Bibin reaction. Now, important uses of quinoline, medicinal uses. Drugs used to prevent and treat malaria. Cinchona alkaloids. Example, quinine, quinidine, 4-amino quinolines, chloroquine and amodiaquine, and 8-amino quinoline, example, primaquine and bulaquine. You can see the chloroquine. Now, quinoline antibiotics, very important. Ciprofloxacin, ofloxacin, norfloxacin, lomfloxacin, and sparfloxacin. You can see the structure which contains quinoline. A lot of substitutions here. Now, 8-hydroxyquinoline used as topical antiseptic. You can see here. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.